In this lecture video, we are going to discuss about math functions and adding new functions or user-defined functions. Python provides a rich set of mathematical functions through a module maths (math). The use of this function, the maths module, has to be imported in the code. The sum of the important functions available in maths are given here. So square root, the function name is sqrt function. So this function, it takes the one numeric argument and finds the square root of that argument. For example, maths math is the module dot square root sqrt square root of 34. The argument is 34 and function name is square root and module is mathematical module. So the interpreter will give the square root of the argument value. So here argument is 34. 34 square root value is 5.83. So 34 is the integer argument. So let's consider one more example. Maths dot square root of 21.5. So 21.5 is the argument. The argument is floating point argument. So 21.5 square root value is 4.63. Pi is one of the math function. The constant value pi can be used directly whenever we require. So this is the maths in the module dot pi. The pi is the function name. So it will give the constant values. The values is 3.14. Log 10, this is another function, math function. This function is used to find the logarithm of the given argument to the base 10 value. So for example, you take maths dot log 10 of 2. So this is the log 10. Log 10 is the function. The argument is 2. The resulting value is we get the base 10 values. The resulting value is 0.30. So log of is another function, math function. This is used to compute the natural logarithm, so base e of the given number. For example, you take math.log2, so it will give the natural logarithm output. The output is 0.69. The previous one is base 10 output, so it will give 0.30. The next is sine function. So this is the trigonometric function. As the name suggested, it is used to find the sine value of the given argument. Note that the argument must be in a radians, not degrees. One can convert the number of degrees into radians by multiplying pi divided by 180 as shown below. So for example, so here maths dot sine 90. So 90 we have to find out. So 90 into maths dot pi divided by 180. The result is 1. Sine 90. So we get 1. The next math function is cos function. So used to find the cosine values. So here the module is maths dot cos of. So we have to find out the cos value for 45. So here it's interpreter will give the radians values. So we want values in terms of degree. That's what we are multiplying with maths.pi divided by 180. So interpreter will give the value. The cos 45 we get 0.707. The next function is tan function, the function to find the tangent of an angle. So given as a argument. So for example, you take maths.tan 45 is the argument. So we multiplied with the maths.pi divided by 180. So this is convert the radians into degrees. So here we have to convert the 45 into tan values. So it will give 0.999. The next function is power. This function takes the two arguments, for example x and y, then finds the x to the power of y. So for example, maths dot power, the arguments are 3, 4. It will gives the 84. It gives the 81.
Let's try this in interpreter. So if you want to execute the mathematical models in interpreter, first we have to import the module. So first we will import the module. Import module name is math, math. Now so maths dot square sqrt square root of 34. So here sqrt is the function and maths is the module name. So it will gives the square root of the 34. So here 34 is the integer value. So it will gives 5.83. The next function is pi. So maths dot pi, it will gives the pi values. The pi value is 3.14. The next function is log 10. So log 10 will give the logarithm of the argument value. So for example, you take maths dot log 10 of 2. So 2 is the argument value. It will gives the log base 10 value. So it's equal to 0.30. So log maths dot log of 2. So this is the natural logarithm. It will gives the natural logarithm output. So it will gives the 0.69. The next function is sine function. So for example, you take maths dot sine of 90 into maths dot pi divided by 180. So it will gives the sine 90 value in terms of degree. So here maths dot pi divided by 180 is converts the radians into degrees. So interpreter will gives the sine 90 value. So it's equal to 1. So let's consider one more function, cos. So maths dot cos of 45 into maths dot pi divided by 180. So it will gives the cos 45 values. Cos 45 value, the value is 0.70. So let's consider one more function. The function is tan maths dot tan of 45 degree into maths dot pi divided by 180. So it will gives the tan 45 degree values. So it's equal to 0.99. So let's consider one more function, power function. The power function will gives the power values. So for example, you take maths dot power 3 comma 4. So power 3 comma 4, it's equal to 3 to the power 4. So it will gives the 81.
So we know that function we mainly classify into two types. The first one is built-in function and second is user-defined function. Now we will look into user-defined functions. The Python is facilitates the programmer to define his or her own functions. The function written once can be used whenever is required. The syntax of the user-defined function is, so this is the syntax. So here def and function name and argument list, and these are the statements, and this is the return value. Here def, so this is the def is the keyword is indicating it as a function definition. So def is indicate the function definition. Function name fname is a valid name given to a function. So this is the user defined name. So argument list is a list of the argument is taken by the function. These are treated as a input of the function from the position of the function call. There may be a 0 or more arguments to be a function. So these statements are the list of the instruction to perform the required task, and return is a keyword is used to return the output value. So this is return statement is optional. The first line in the function def fname of argument list is known as a function header or definition. So this is the header. The remaining lines is constitute the function body. So remaining lines are the body. This is header and these are the bodies, function bodies. The function header is terminated by a colon and the function body must be indented. So this is the terminated by colon and function body must be indented. To come out of the function, indentation must be terminated. So unlike few other programming languages like C, C++, etc., there is a no main function or specific location where a user-defined function has to be called. The programmer has to invoke or call the function wherever is required. Let's consider one example. So here a is equal to 30 we assign to a and 20 we assign to b. So here we are going to print the sum value. Sum is a plus b, and next printing statement is a minus b. Next statement is a multiplied with b. Here A is assigned to 30 and B assigned to 20. So here results are 50 and here we get result is 10, 10 and again the result is product of these two we get 600. Our first requirement is 30 and 20. So again our requirement is the inputs are 300 and 200 and task is printing statements are sum, difference and multiplication. So here we get the sum value, difference value and multi product values. So and again next our requirement is our user inputs are 3000 and 2000. So task is our printing statements are sum, difference and product. So here we get the sum of the 3000 plus 2000, result is 5000 and difference of a minus b and result is 1000 and here we get the product of these two values. So here we return one program without any functions. Now we are going to write the same programs with functions. So here we declare function. The def is the function definition and calculate is the function name and our function name and arguments are a and b. So this is the def is the keyword and calculate is the function name and a comma b is the argument. Here print the sum is a plus b. This is the first printing statement on first task and second task is a minus b and next one is a product b. So here we call the function. The function name is calculate. So calculate of 30 comma 20. So and this is the first argument and this is the second argument and here so this is the header, function header. So and here arguments, this is the first argument and this is the second argument. So here we assign the integer value 30 and 20. Here 30 is equal to a and 20 is equal to b. So if you execute this, so we get the sum value here. So sum is equal to 30 plus 20. Here we get the 50 and here subtracted value is 10 and here we get the product value 600. Again we call the function. The here arguments are 300 and 300 comma 200. So if you execute this, so we get the sum of these two, difference of these two and product. So again you call the function name calculate and arguments are 3000 and 2000. If you execute this, so we get the sum, difference and product value. So here so without function we return the program and number of lines are 15. So here number of lines are 7. Number of lines are 7. So if you use the function, so we can easily reduce the lines, code lines, and the main advantages of the function is reusability. Whenever so we want the whenever is required, so we can call the function. So once we assign the functions and this is the body and this is the header, here we call the this is the first function call and this is the second function call and this is the third function call. So multiple times we can call the functions. Let's consider one more example. So here 10 we assign to a and definition, the function name is display. Here arguments are 0. Here then we assign b is equal to 20 with indentation. So this is the indentation. Then we are going to print a and print B, and here we call the function. The function name is display. So here A is equal to 10 we assigned initially. So function before function definition, so this variable A variable is act as a global. So here we assigned 20 to B, so this is the local variable. So here A is equal to 10 is the global variable, and B is the local variable. So if you print this, the interpreter will give the value 10 and 20. So print A, this is the printing statement, it will print the A, and A assigned value is 10, and print B is assigned value is 20. Let's consider one more example. So here A is equal to 10, so this is the global declaration, and function def display, function name is display. Here we declare B is equal to 20, and print statement is print A and print B, and here we call the function. So the result of this is, so it prints the 10 and 20, 10 and 20 again. So here we declare C is equal to 40, 40 we assign to C, and again we are going to print A and C. So A value is global value A, and again we declare C is equal to 40. So here if we execute the entire code, so print value is, here the print value is 10, and here the printed value is 40. The final result is, the final output is 10, 20, 10 and 40. Just you observe here we define the function, and here this is the indentation. So this indentation is indicate, so B value print A and print B is belongs to display functions, and just you observe here C we declare without any indentation. So here and print A and print C we declare without indentation. So here the print values are A and printed value is C, 40 and 10. So here printed values are 10 and 20. Let's consider simple example of user defined function. So here the user defined function is def is the keyword, and my fun is the function name, and arguments are 0. So this is the function header, and here we are going to print hello print inside the function, and again we are going to print example of function. Here we call the function name. So the function name is my fun. Here we call the function name, and again we are going to print the example over. So here we declare 4 printing statements. So this is the first print statement, this is the second printing statement, and this is the third printing statement, and this is the fourth printing statement. So if you execute this, the Python interpreter is going to print the statement 3 first, then it's going to print the statement 1, statement 2 and fourth statement. The program output would be, the first output is example of the function, this is the output, and next is hello, and next is inside the function, and next is example over. Just you observe the indentation. So this is the header, here the print allow, so we declare with indentation, and print inside the function we declare with indentation. The statement, printing statement 1 and printing statement 2 is belongs to function, so third printing statement, so we have not give any space, we are declare without indentation. The printing statement is example of function. Here we call the function. The function name is my function. And again we declare one more printing statement without any indentation. The printing statement is example of over. So in function, the execution flow is the sequential order. So here, so the statement print example of function is going to execute first, and output is example of function. After that we are calling function. The function name is my function. So function under function the printing statements are two. The first printing statement is hello and second printing statement is inside the function. So it's going to execute these two, and the outputs are hello and inside. The next interrupter is going to execute the print example over. The result is example over. So here the output of the above program would be example of function allow inside the function and example over. The function definition creates an object of type functions. So in the previous example, my fun is the internally an object. This can be verified by using the statement the print my fun, the my fun without a parenthesis. So here the function my fun is stored at 0x021 location. So the type of the my fun is function. The my fun without parenthesis is the function. So here the first output is indicate the myfun is object which is being stored at the memory address. The memory address is 0x. So 0x is indicates octal numbers. The second output is clearly shows myfun is the type function. So this is the second statement. The class is function. So note that in fact in Python every type is in the form of class. Hence when we apply type on any variable or object, it displays respective class name. The flow of execution of every program is sequential form. Top to bottom of a function can be invoked only after defining it. The usage of function name before its definition will be generated error. Observe the following code. So here the print example of functions and my fun, the function called before definition. So before definition we call the function the print example over. So here we define the function. So def my fun, the function is defined here. Here the print allow and print inside the function. The above code would generate the error saying naming error. Name myfun is not defined. The functions are meant for the code reusability, that is a set of the instruction written as a function need not be repeated. Instead, they can be called multiple times whenever we require. So consider one more example. So in this example, we are declared two functions. This is the first definition. The first definition is def myfun is the function name, and print statement is inside myfun. So inside myfun, this is the indentation. So this print statement is belong to first definition. Again we define the one more function. This is the second definition, and the indentation, within indentation we return my fun. Print statement is inside repeat, and again we call the function my fun. So after that we return print example of function. Here we call the function repeat. Repeat is the second definition function name, and here we print the example is over. So if you execute this in interpreter, the execution is start here. So the first execution is print example of function. So Python interpreter will print the example of the function inside. So this is the first execution. Next is going to execute the function call. So here function call is repeat. So its repeat is moved to second definition. So it will print my fun, and print statement is inside repeat. So this is the second print statement, my fun inside the repeat. So after that, so again we called my fun. So my fun is moved to first definition, and first definition print statement is inside my fun. So third execution is inside my fun. So at the end, the interpreter is going to execute the print example over. So at the end, print example over is executed. The execution is start here. This is the first one, and later execution is start here, second one, and this is the third one, and this is the fourth one, and this is the fifth execution, and this is the last execution. So this is the output example of the function inside my fun, inside repeat, inside my fun, and example over.
Let's try this in interpreter. So here, so we are define one function definition def, and we are going to calculate the a and b value. The calculated value is sum of the numbers, difference and multiplication. Here we call the function. So calculate 30, 20, this is the first function call. Calculate 300, 200 is the second function call, and third call is 3000, 2000. Here definition is the keyword, calculate is the function name, and arguments are a, b. So here we are going to print the sum is a plus b, the print difference is a minus b, and print product value, the product value is a star b. So just you run this code. So first we have to save the file. So here we get the number. The first answer is this is the first set of answer, 50, 10 and 600. This is the first set, first call answer, and second function call results are 500, 100, 60,000. The next function call answers are 5,000, 1,000 and 6 lakh. So let's consider one more example. So here a is equal to 10, and this is the global declaration. So here we define the function def, and function name is display. So again we assigned 22 variable b. So here we are going to print a and b. So a and b belongs to function. So this is the indentation. So b is equal to 20, print a, and print b belongs to definition. So here we call the function name is definition. Again we declare one more variable c, and assigned value is 40, and again we are going to print a value and c value. So here a is 10 and b is 20 and c is 40. The first instruction, Just you execute this code, run. So here display values are 10, 20, 10 and 40. Let's look at here. So here we call the functions. So here print a is belong to function and print b is belong to function. So a assigned value is 10 is going to print first, and b is belong to function, it's going to print second, and next we assign one variable c and assigned value is 40, and next print statement is a and a value is 10. Next we are going to print the c and c assigned value is 40. The final result is 10, 20, 10, 40. So let's consider one more example. Here we declare the function definition def and name is myfun. The printing statement is print allow and print inside the function. So again, so print statement 1 and print statement 2 is belong to function definition. Again we are going to print example of the instruction, and after that we call the function. The function name is myfun parenthesis. So after that we are going to print example is over. So here we call the function. We have two print statement. This is the first print statement, and this is the second print statement, and this is the third print statement, and this is the fourth print statement. So here the Python interpreter is going to print this first. After that is going to print the myfun print statement. So myfun print statements are allow and inside the function. So at the end it's going to print the example is over. Just you run this. So it's going to print example is example of the function. Example of the function is going to execute first. After that allow. After that inside the function at the end is going to print example over. These are some references. Thank you.